Okay, Assalamu alaikum students. So let's get started with A2 Physics, October November 2025, Paper 4, Variant 1. This is A2 Physics, Paper 4, 2 hour ka paper. Let's get started with it. Bismillah Rahman Rahim. So let's see this first question. सबसे पहले first question को देखते हैं. Let's see this. In terms of velocity and acceleration, define what uniform circular motion means. आपने यूनिफॉर्म सर्कुलर मोशन ऑफ एन ऑब्जेक्ट को डिफाइन करना है. फर्स्ट ऑफ ऑल लेट्स डिफाइन सर्कुलर मोशन. बेटा सर्कुलर मोशन की क्या डेफिनेशन होती थी? व्हाट यूज्ड टू बी द डेफिनेशन ऑफ सर्कुलर मोशन? सर्कुलर मोशन की क्या डेफिनेशन होती थी? Velocity and acceleration are perpendicular. What is the definition of uniform? That the magnitude of velocity and acceleration is constant. ठीक है, तो बेटा यहाँ पे दो वर्ड्स हैं, यूनिफॉर्म एंड सर्कुलर मोशन. मैग्नीट्यूड ऑफ velocity and acceleration are constant due to the uniform covered. Circular motion means that velocity and acceleration are perpendicular to each other. Let's write this entire thing in a correct grammatical format. So you will say, you can easily say here, let me do one thing. Yeah. You can say here that velocity is perpendicular to acceleration. This defines circular motion, and the magnitude of velocity and acceleration is constant. Magnitude of velocity and acceleration is constant. Simple. Figure 1.1 shows the view from above a polystyrene ball undergoing horizontal circular motion. अच्छा जी, of radius r. So this is a ball of polystyrene that is going horizontal circular motion of radius r. Perfect. This is your radius r. This is your radius r. This is your polystyrene ball. Okay. The ball is illuminated by parallel light. Okay, the ball is illuminated by parallel light so that the shadow of the ball forms on a screen placed on the opposite side of the wall from the light source. अच्छा जी, ये आपके पास screen है. Here you can see the shadow of the ball. So here you have the shadow of the ball. This is the screen where you can see the shadow. Okay. What else is given? The line joining OP is perpendicular to the screen. What is line OP? This line OP is perpendicular to the screen. Okay. The angular speed of the circular motion is W. ठीक है, W is your angular speed. State an expression in terms of R and W for the speed V of the ball. Do you remember that the linear speed is equal to what? Radius R into the angular velocity, that is W. Your linear speed is equal to what? Radius R into the angular velocity of W. Determine an expression in terms of V and W for the centripetal acceleration of the ball. Do you remember that centripetal acceleration can be written as RW square? If you realize RW square can be written like this. What is RW equal to? RW is equal to V multiplied by W is equal to your centripetal acceleration EZ. आगे बढ़ते हैं. The ball in B is in the position shown in figure 1.1 such that line OB is at an angle theta to the line OP. ठीक है, ये line OB जो है, this is making an angle theta with the line OP. Perfect. Determine an expression in terms of r and theta for the displacement x of the shadow from P. Okay, so yeah, we have to determine an expression for this x. ये x कैसे निकालेंगे? Let's assume this is a line perpendicular. This is also equal to x. Can you realize this entire thing is a right angle triangle? Because this entire thing is a right angle triangle. Yes. How will you calculate this x? If you realize this is your perpendicular, this is your hypotenuse, what will you say? Sine of theta is equals to perpendicular, that is x, divided by the hypotenuse, that is r. R sine theta is equals to your value of x. Simple. So you can write here. You can say beta r sine theta is your value of x. Now the value of theta is 0 at time t is equals to 0. Acha, value of theta is 0 at time t is equals to 0. State an expression for theta in terms of w and t. Very easy. क्या लिखोगे? W is equals to theta, that is angular displacement, divided by time. If you want to give an expression for theta, what will you do? Theta is equals to W into T. Simple. This is also done. Use your answer in C part 1, that is this answer, and use your answer in C part 2, that is this answer, to show that x is given by this equation. Beta, we know that x is equals to r sine theta. And luckily enough, we also know that theta is equals to wt. तो बेटा इस थीटा की जगह आपने क्या सब्स्टिट्यूट कर देना है? wt. x is equals to r sine wt is your equation. Simple. Let's further move ahead. Explain with reference to equation 3 why the motion of the shadow of the ball on the screen may be modeled as simple harmonic motion. बेटा हमने बताना है कि why can we model the motion as simple harmonic motion. मोशन को हम simple harmonic motion की तरह क्यों मॉडल कर सकते हैं? If you realize this equation, x is equals to r sine wt is identical to the general equation of simple harmonic motion, that is x is equals to x naught sine wt. बेटा ये क्या है? This is the general equation of simple harmonic motion. This is pretty identical to the equation that we have in C part 3. Okay. So what will you say here? What will your answer look like? क्या कहोगे यहाँ पे? You will say equation of x is equals to r sine wt is identical to the general equation to the general equation of simple harmonic motion, that equals to x is equals to x naught sine wt. Now just as a revision, एक और बात भी मुझे यहाँ पे बता दो बेटा. एक और बात क्या बता दो कि this x naught is equals to what? X naught is equals to your amplitude. ये बात याद है सिंपल हार्मोनिक मोशन से? दिस x naught is your amplitude. What is w? W is your angular frequency. चलो जी आगे बढ़ते हैं. Let's move ahead. अच्छा, the circular motion of the ball in figure 1.1 has a diameter of this. Okay, this is your diameter. And an angular speed of this. Okay. For the simple harmonic motion of the shadow of the ball in figure 1.1, calculate the amplitude. अच्छा हमने amplitude निकालना है. How will we do that? Okay, so you have to determine the amplitude. Amplitude किस तरह determine करेंगे बेटा? We know x is equals to x naught sine wt is your general equation of simple harmonic motion, जिसमें x naught is your amplitude. x is equals to x naught sine wt में x naught क्या है? आपका amplitude. What is the equation of x जो आपने calculate की है? X is equals to r sine WT. Can you realize your amplitude of x naught is equals to what? Is equals to the radius r. Amplitude of x naught is equals to your radius r. You are given the diameter. आपको diameter given है, that is 0.46. How will you calculate the radius? Divided by 2. 46 divided by 2. What does your answer comes out to be? 0.23 meters. X naught किसके equal हो गया? Amplitude किसके equal हो गया? Equal to the radius, that is 0.23 meters. Now you have to calculate the period. How will you do that? Are you given angular speed? W given है आपको? Yes, W is equals to 1.9. W की इक्वेशन किससे रिप्लेस हो जाएगी? 2 pi over capital T. Always remember W is equals to 2 pi over capital T. Instead of W, I wrote 2 pi over capital T. 1.9 यहाँ पे आ गया. 2 pi divided by 1.9 is equals to your time period. That is capital T. Can you calculate this answer? हाँ जी बेटा, can you calculate this answer? Time period comes out to be what? 3.3 seconds. Okay. Now you have to calculate what? You have to calculate the maximum acceleration. Maximum acceleration का क्या formula होता है? A naught is equals to W square x naught. What is W? 1.9 का square. What is x naught? 0.23. Multiply कर दो बेटा. What does your answer comes out to be? हाँ जी, आंसर क्या आ रहा है बेटा? The answer comes out to be 0.83 meters per second square. Simple, easy peasy, nothing complicated here. Let's further move ahead. आगे देखते हैं. On figure 1.1, draw and label with letter A the position of the shadow on the screen when the shadow has its maximum positive acceleration. देखो बेटा, we are performing simple harmonic motion, है ना? We are performing simple harmonic motion. If you want to have acceleration as maximum positive, what will happen to your displacement? Displacement will be maximum negative. बेटा, simple harmonic motion में acceleration and displacement used to move in opposite direction. If you want to have the acceleration in the maximum positive direction, the displacement will be in the maximum negative direction. Sir, where can we have the maximum negative displacement? On the left side here. This is your maximum negative displacement. And make sure that this is your displacement that is equals to negative r. बेटा, आपकी displacement negative r के equal है, negative radius के equal आपकी displacement है. You make a dotted line here. This is your position A. Now, time and again, whenever I solve past papers, I get this question, so let me clarify it. बेटा, your displacement is equals to negative of radius. आपका radius negative नहीं हो रहा. Your radius is still positive, but your value of displacement is equals to the negative of radius. Please make sure that you understand this difference. Let's move on to the next one. Okay, this question is done. Let's move on to question 2. State two ways in which the first law of thermodynamics describes that the internal energy of the system can be changed. So, do you remember the first law of thermodynamics? Internal energy is equals to Q plus work done on the gas. If you want to change the internal energy, what can you do? Either you can supply the thermal energy or remove the thermal energy. तो ये पहला change हो गया. Thermal energy supplied to or removed from the system. Basically, if you change the value of Q, your internal energy changes. बेटा, अगर आप Q की वैल्यू को चेंज करते हो, your value of internal energy will change. अच्छा, what about work done on the gas? Same. If you change the value of work done on the gas, your value of internal energy will also change. बेटा, दोनों में से कोई भी वेरिएबल, either Q या work done on the gas में से कोई भी चीज़ चेंज करोगे, your internal energy changes. So you can say work done ऑन द गैस को भी अगर आप चेंज करोगे, ऑन द सिस्टम को भी अगर आप चेंज करोगे, तो योर इंटरनल एनर्जी चेंजेस. ओके. Use first law of thermodynamics to explain why a bicycle pump gets hot when it is used to pump up a tire quickly. Whenever you see these words, quickly हो गया, suddenly हो गया, immediately हो गया, whenever you see these words, always remember that your transfer of thermal energy becomes zero. Whenever आप ये words देखते हो, quickly, suddenly, immediately, your transfer of thermal energy becomes zero. Q is equals to zero. तो यहाँ पे लिख लो. यहाँ पे you can write this as your first key point. You can say, where should I keep it? Yeah, here. Let's highlight this. You can say no thermal energy is transferred to the system. No thermal energy is transferred to the system because the process happens quickly. Now please, please, please focus on the board. फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स क्या कहता है? फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स क्या कहता है? चेंज इन इंटरनल एनर्जी इज इक्वल्स टू क्यू प्लस वर्क डन on the gas. This value of Q has become zero because we are performing the process very quickly. Change in internal energy is equals to work done on the gas. Now, can you realize that we are compressing the gas? Can you realize we are compressing the gas? We are decreasing the volume of the gas. If you are decreasing the volume of the gas, you are compressing the gas. Your work done on the gas will be positive. Hence, your change in internal energy will be positive. If your change in internal energy is positive, or if your change in internal energy is increasing, your temperature will increase, your pump will become hot. So this is what we will write in the next remaining lines. You will say, oh, as the gas is compressed, the work done on the gas becomes positive. The work done on the gas becomes positive. What will be your next line? Anji. As the gas is compressed, the work done on the gas becomes positive. Since work done on the gas is positive, change in internal, you can write the complete thing. I think students get confused on minor things, so let me write the complete thing. Since work done on the gas is positive, change in internal energy of the gas is also positive. This causes the temperature to increase. Temperature to increase. Simple. Let's further move ahead. With reference to molecular energies, explain why the temperature of water remains at 100 degrees centigrade when it vaporizes in a kettle even though it is heated. बेटा बॉइलिंग के दौरान why does your temperature remains constant even though you are providing heat energy? We have discussed this exact thing in the notes and in the lecture videos. What will you say? During vaporization, what happens? Kinetic energy of molecules remains constant. Hence, the temperature of water remains constant. उसके आगे क्या लिखोगे बेटा? What will you write further? You will say all the heat energy provided, all the heat energy provided causes the separation, causes the separation between the molecules to increase, causes the separation between the molecules to increase. Last point क्या होगा? As the separation between molecules increase, between molecules increase, what will happen? Elastic potential energy increases. Simple as that. Nothing complicated here. Easy peasy, lemon squeezy. Let me again not take a shortcut here. Basically, my students are all of them know how I write shorthand, but on YouTube, I have to go in detail. As the separation between molecules increase, the potential energy between molecules increase. Simple, nothing complicated. आगे बढ़ते हैं. Define gravitational field at a point. What is the definition of gravitational field at a point? Force per unit mass. Force per unit mass. This is your gravitational field की definition. Figure 3.1 shows an isolated mass of capital M. Okay, this is the isolated mass of capital M. Point P is at a distance x from the point mass. अच्छा जी, point P क्या है? At a distance of x from the point mass. By considering the force exerted by the point mass on a test mass of mass small m placed at P. अच्छा जी, यहाँ पे अगर आपने एक टेस्ट मास प्लेस कर दिया small m, drive an equation for gravitational field strength at P. Okay, so you have to calculate the gravitational field strength at P in terms of capital M and X. Okay, how will you do that? Always remember gravitational field strength is equal to the gravitational force divided by the point mass, that is the small mass. ग्रेविटेशनल फोर्स की क्या फॉर्मूला होता है? कैपिटल जी कैपिटल एम स्मॉल एम डिवाइडेड बाय एक्स स्क्वायर. टेक दिस डिवाइडेड बाय एम. Gravitational field strength is equal to what? Capital G, capital M, small m divided by x squared divided by m. Cancel, cancel. Gravitational field strength का फॉर्मूला क्या हो जाएगा? The gravitational field strength is equal to capital G, capital M divided by x square. Identify any other symbols that you use. We have used m. M का given था. x भी given था. What is capital G? Capital G is your gravitation constant. And what is the value of gravitation constant? Hanji, 6.67, 10 raised to the power of minus 11. You can also look this up in the data table. बेटा जो शुरू में आपको data table given है वहाँ पे भी given है. Gravitational constant G is equals to 6.67, 10 raised to the power of minus 11. Simple. Let's further move ahead, I guess. Okay. On figure 3.1, draw an arrow to indicate the direction of gravitational field at P. Always remember, the gravitational field is always attractive. बेटा gravitational field हमेशा attractive होगी. So how will a force act at P? There will be a force towards the capital M. बेटा हमेशा याद रखो ग्रेविटेशनल फोर्स अट्रैक्टिव होती है. इट विल कॉज द पॉइंट पी टू मूव टुवर्ड्स कैपिटल एम. ओके. पॉइंट क्यू इज अ डिस्टेंस ऑफ एक्स ओवर टू फ्रॉम द पॉइंट मास. अच्छा जी, पॉइंट क्यू क्या है? डिस्टेंस ऑफ एक्स ओवर टू फ्रॉम दिस पॉइंट मास कैपिटल एम. ओके. on the opposite side of mass from P as shown in figure 3.2. ठीक है, point Q left side पे है, point P right side पे, perfect. Compare the gravitational field at Q and compare the gravitational field at P. Always remember, gravitational field is always attractive. Gravitational field is always attractive. So this capital M का मास अट्रैक्ट करेगा Q को भी इस तरह. This is your gravitational field strength at Q. This capital M का mass will also attract P. This is the gravitational field strength at P. This is the gravitational field strength at Q. Can you realize both the gravitational fields are acting in opposite direction? This gravitational field at Q is acting towards the right. The gravitational field at P is acting towards the left. How will you write this first point? You will say the gravitational field, the gravitational field at P and Q are in opposite डायरेक्शंस. बेटा पी और क्यू पे जो आपकी ग्रेविटेशन फील्ड है वो ऑपोजिट डायरेक्शंस में है. फर्दर मोर, if I ask you to calculate the gravitational field strength at Q, how will you do that? Capital G, capital M divided by the distance between Q and M, that is x over 2 whole square. This comes out to be what? Gravitational field strength at Q comes out to be what? Capital G, capital M, x square divided by 4. Take this to the top side. ग्रेविटेशनल फील्ड स्ट्रेंथ एट क्यू किसके इक्वल हो जाएगी? 4 कैपिटल जी कैपिटल एम डिवाइडेड बाय एक्स स्क्वायर is equals to your gravitational field strength at Q. If I ask you to calculate the gravitational field strength at P, how will you do that? Capital G, capital M divided by x square. Can you realize a fact? ये आपकी gravitational field strength है at point P. This is your gravitational field strength at point Q. Can you realize something? This capital G capital M over x square किसके इक्वल है? कैपिटल G कैपिटल M over x square किसके इक्वल है? Gravitational field strength at P. So you can say that the gravitational field strength at Q is 4 times the gravitational field strength at P. You can write this. The gravitational, you can write this, the gravitational field strength at Q is 4 times the gravitational field strength at P. Simple. आगे बढ़ते हैं बेटा. Let's move ahead. Two identical isolated uniform spheres x and y each have a radius of r. अच्छा जी, इसका भी radius r है and this also has a radius of r. Perfect. The center of the spheres are separated by a distance of L. Okay. As shown, perfect. Point P lies on the line joining the center of the spheres x and y and is at a variable distance x from the center of the sphere x. Okay, ठीक है. The gravitational field strength at the surface of each sphere is G नॉट. बेटा यहाँ पे भी आपकी ग्रेविटेशनल फील्ड स्ट्रेंथ सरफेस पे G नॉट है, यहाँ पे भी G नॉट है. Now again I would like you to recall one key point. Gravitational field strengths are always attractive. Gravitational field strength क्या करती हैं? हमेशा attractive होती हैं. So at point x, the gravitational field strength is attractive. It will act inward. G naught. At point y, the gravitational field strength is attractive. It will act inward. G naught. Now you can say that the right side vectors are positive, left side vectors are negative. Gravitational field strength at x can become negative g naught. Gravitational field strength at y can become positive g naught. क्योंकि gravitational field strength वेक्टर क्वांटिटी है, डिपेंड्स ऑन डायरेक्शन. राइट साइड वाली को हमने पॉजिटिव जी नॉट कह दिया, लेफ्ट साइड वाली को नेगेटिव जी नॉट कह दिया. ओके. On figure 3.4, sketch the variation with x of the gravitational field strength at point y between x is equals to r till x is equals to l minus r. ठीक है, हमने ग्राफ बनाना है. You must remember that at a distance of r, your gravitational field strength is negative g naught. At a distance of l minus r, gravitational field strength is positive g naught. Also, bache, can you realize both these gravitational field strengths are identical? Write down a key point. When two objects have identical, when two objects have identical gravitational field strength, this is very important. When two objects have identical gravitational field strength, the null point lies in the middle. Lies in the middle. बेटा जब दो ऑब्जेक्ट्स की आइडेंटिकल ग्रेविटेशन फील्ड स्ट्रेंथ होगी, नल पॉइंट कहाँ पे लाई करेगा? इन द मिडल. At null point your gravitational field strength is 0. It lies in the middle. L over 2 from here. L over 2 from here. So you can say at a value of L over 2 your gravitational field strength becomes 0. Can you draw the graph? Yes. Like this. And like this. Simple. Easy peasy. This is how you will draw your graph. Nothing complicated. 3 on 3 here. Let's further move ahead. State the value of absolute 0 on the Celsius scale. On the Celsius scale, absolute 0 is negative 273.15 degree centigrade. The thermodynamic temperature scale पे absolute 0 की value क्या है? 0 Kelvin. Perfect. A sample contains a fixed amount of gas. Okay. The gas has pressure P, volume V and thermodynamic temperature T. अच्छा जी, गैस का प्रेशर P है, वॉल्यूम V है, thermodynamic temperature T है. Okay. Figure 4.1 shows the variation of PV with KT for the sample. K is the Boltzmann constant. अच्छा जी, PV versus KT का ग्राफ गिवन है. K is your Boltzmann constant. Easy peasy. आगे देखते हैं क्या करना है हमने. State what is indicated about the nature of gas from the variation shown in 4.1. बेटा ये जो वेरिएशन आपको दिख रही है, इसकी वजह से आप नेचर ऑफ द गैस के बारे में क्या प्रेडिक्ट कर सकते हो? कैन यू रियलाइज दैट द ग्रेडियंट ऑफ दिस ग्राफ इज इक्वल टू व्हाट? चेंज इन y ओवर चेंज इन x. बेटा इस ग्राफ का ग्रेडियंट किसके इक्वल होगा? चेंज इन y ओवर चेंज इन x. pv over kt. Can you realize that the gradient of this graph is equals to pv over kt? Since this graph is a line, क्योंकि ये ग्राफ एक लाइन है, that means what? The gradient of this graph is constant. If the gradient of this graph is constant, that means PV over KT is constant. If PV over KT is constant, K, that is the Boltzmann constant, is already a constant. और अगर आपका PV over T का ratio is also constant, what does this mean? If your PV over T ka ratio is constant, what does this mean? You have an ideal gas. So you can say, state what is indicated by the nature of the gas. The gas is an ideal gas. Simple. Determine the number of molecules n of the gas in the sample. हमने number of molecules n determine करने हैं. How will we do that? Do you remember this formula? PV is equals to NKT. ये फॉर्मूला याद है? PV is equals to NKT. PV divided by KT is equals to your N. बेटा PV over KT किसके इक्वल है? PV over KT is equals to the gradient of the graph. The gradient of the graph will be equal to the number of molecules. So, sir, how can we calculate the gradient of the graph? Very easy. Take one point as 0, comma 0 and the other point as 8, comma this is 270. Obviously, you can calculate the gradient directly using this point as well. Yeah, you can calculate the gradient directly using the second point as well because the line is passing through the origin. But I like to simplify things as much as possible. 0, comma 0, 8, comma 270. Can you realize this is x1, this is y1, this is x2, this is y2. Can you calculate the gradient? Gradient निकाल सकते हो बेटा y2 minus y1, x2 minus x1. What is the value of y2? 270. y1, 0. What are the units on the y-axis? Joules, no need to convert. What is x2? 8. What is x1? 0. What are the units on the x-axis? 10 raised to the power of minus 21. Can you calculate the number of molecules? Number of molecules निकाल सकते हो बेटा. The number of molecules comes out to be 3.4 10 raised to the power of 22 number of molecules. Simple. Let's further move ahead. Use your answer in B part 2 to determine the number of moles of the gas in the sample. बेटा अब आपने number of moles को determine करना है. How will you do that? 1 mole has how many molecules? 6.02 10 raised to the power of 23 number of molecules. 3.4 10 raised to the power of 22 molecules किसके पास होंगे? 3.4 into 10 raised to the power of 22 molecules. How many moles? अगर एक मोल 6.02 10 raised to the power of 23 molecules के इक्वल है 3.4 into 10 raised to the power of 22 molecules कितने moles के इक्वल होंगे? What does x comes out to be? x is equal to 0.056 moles. Simple. आगे बढ़ते हैं. The root mean square speed of the molecules is this. Okay. This is what? This is your CRMS, or you can say speed की value. When PV is 270 joules. Determine the mass in U of one molecule of the gas where U is the unified atomic mass. बेटा U की value क्या होती है? 1.66 10 raised to the power of minus 27 kg. Okay. So basically, let's start simple. हमें पता है kinetic energy of an ideal gas is equals to 3/2 kT. Kinetic energy की जगह बेटा आप क्या लिख सकते हो? 1/2 mc square is equals to 3/2 kT. कुछ कैंसिल आउट हो रहा है बेटा? 2 2 कैंसिल आउट. Mass of the gas is equals to 3 kT divided by c square. Beta, what is the value of K? 1.38 10 raised to the power of minus 23. टेम्परेचर की वैल्यू क्या है बेटा? टेम्परेचर की वैल्यू क्या है? नहीं पता. Now this is where you have to utilize the graph. बेटा यहाँ पे ही आपने ग्राफ को यूटिलाइज करना. इफ यू डू इट द नॉर्मल वे you will get stuck because you don't know the value of t. So let's not do it the normal way. Can you realize the value of PV is 270? When the value of PV is 270, what is the value of KT? 8 into 10 raised to the power of minus 21. You can directly plug and play. 3 into 8 into 10 raised to the power of minus 21 divided by c square. What is the value of c? 1900 ka square. Can you calculate the mass? This mass comes out to be 3 into 8 into 10 raised to the power of minus 21. ठीक है. डिवाइड कर दो बेटा इसको 1900 के स्क्वायर से. This comes out to be 6.65 10 raised to the power of minus 27 kg. The mass of one molecule comes out to be this. But you don't have to give the mass in kgs. आपने तो mass को u की terms में देना है. If 1 u is equals to 1.66 10 raised to the power of minus 27 kg, 6.65 10 raised to the power of minus 27 kg will be equal to how many u? X. Calculate the value of x. 6.65 10 raised to the power of minus 27 divided by 1.66 10 raised to the power of minus 27. Can you calculate the value of u's? इसको अगर हम डिनोमिनेटर में रखें 1.66 10 raised to the power of minus 27, the value of u comes out to be 4u as your answer. Simple, nothing complicated here. Let's further move ahead. Define electric potential at a point. आपने क्या डिफाइन करना है? You have to define V. Or electric potential at a point, you will say electric potential is what? Work done per unit charge in moving a positive charge from infinity to any point in the electric field. लिख लो ये. Work done per unit charge in moving a positive charge from infinity to any point within the electric field. Simple as that, nothing complicated here. Let's further move ahead. A hydrogen atom may be considered to consist of a proton and an electron separated by a distance of 120 picometers. अच्छा जी, प्रोटॉन और इलेक्ट्रॉन कितने डिस्टेंस से सेपरेटेड है? 120 पिकोमीटर. दिस पिको इज इक्वल्स टू व्हाट? 10 raised to the power of minus 12. ठीक हो गया. The two particles may be considered as point charges. Point P lies on the line joining the electron and the proton and is at a variable distance of x from the proton. ठीक है भाई, ये at a variable distance of x है from the proton. Okay. Show that the electric potential V at point P, that is x is equals to 10 picometer, is equals to this. अच्छा जी, बेटा आपने टोटल इलेक्ट्रिक पोटेंशियल निकालना है व्हेन x की वैल्यू इज 10 picometer. How will you calculate the total electric potential? Total electric potential is equals to the electric potential due to the proton plus the electric potential due to the electron. Simple. Now, please focus on the board. Focus on the board very carefully. This is very important. If you have to calculate the electric potential due to the proton, ये कैसे निकालोगे बेटा? If you have to calculate the electric potential due to the proton, how will you do that? Geniuses, any ideas? Yes, any sensible ideas? How will you calculate the electrical potential due to the proton? Very easy बच्चे. अगर आपने प्रोटॉन की वजह से इलेक्ट्रिकल पोटेंशियल निकालना है, हाउ विल यू डू दैट? चार्ज ऑफ प्रोटॉन divided by 4 pi E naught multiplied by the, or you can say divided by the distance between the proton and point P. इसको x भी कहते हैं कुछ लोग इसको r भी कह देते हैं. Let me write down the formula of electric potential for those geniuses who have forgotten that. Electric potential का formula क्या होता है? 4 pi E naught r. R is the distance between the charge and the point. R क्या होता है? Distance between the charge and the point. हमेशा ये बात याद रखना. R क्या होता है? Distance between the charge and the point. बेटा ठीक हो गया. अब यहाँ पे थोड़ा सा गौर करो, ठीक है? What should I do first of all? चलो मैं साथ साथ कर देता हूँ. Let's do it साथ साथ ही, ठीक है? First of all, if you have to calculate the total electric potential, you will take the electric potential of proton plus the electric potential of electron. How do you calculate the electric potential of proton? Charge of proton divided by 4 pi E naught multiplied by the distance x, that is 10 picometers. Plus, how will you calculate the electric potential due to the electron? Charge of electron plus 4 pi E naught. What will be your distance? Distance क्या होगा बेटा? Can you realize that the total distance is 120 picometer? If x is 10 picometer, what will be the distance from the electron to point P? बेटा अगर टोटल डिस्टेंस 120 पिकोमीटर है एंड आपका डिस्टेंस फ्रॉम द प्रोटॉन टू पॉइंट पी इज 10 पिकोमीटर, what will this remaining distance be? The one I have highlighted in pink. Or let's do one thing. This total distance is 120 picometer. Out of this 120 picometer, ये distance 10 है. What is this remaining distance? This remaining distance is 1110 picometer. यहाँ पे क्या आ जाएगा? 1110 10 raised to the power of minus 12. Because pico की power क्या होती है? 10 raised to the power of minus 12. Now let's do the maths. Let's do the complicated maths here. What is the charge on a proton? 1.6 10 raised to the power of minus 19 divided by 4 pi. Sir, what is this E naught? This is the permittivity of free space. This is also given in the data booklet. यहाँ पे आ जाओ. ये रहा 8.85 10 raised to the power of minus 12. 8.85 10 raised to the power of minus 12. जल्दी 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 नीचे आते हैं. ये रहा 8.85 10 raised to the power of minus 12. Okay. What is your value of x? X की value क्या है बेटा? 10 picometer. Sir, how do we write picometer? 10 raised to the power of minus 12. Plus, what is the charge on an electron? Electron पे charge क्या है? Negative 1.6 10 raised to the power of minus 19 divided by what? 4 pi. E naught की value क्या है? 8.85 10 raised to the power of minus 12. Perfect. What is the distance? 1110 picometer. 1110 into 10 raised to the power of minus 12. Can you calculate this answer? I think this will be a lengthy calculation. 1.6 10 raised to the power of minus 19. I hope I can do it quickly. 4 pi into 8.85 10 raised to the power of minus 12 into the distance, that is 10 into 10 raised to the power of minus 12. ठीक हो गया. Then oh, I have done a grave mistake. एक second. कैलकुलेशन दोबारा हमने करनी पड़ेगी. अल्लाह, एक तो वैसे ही इतनी कैलकुलेशन जो है ये लंबी है, उसके अलावा 4 pi into 8.85 10 raised to the power of minus 12. Also I cannot just tell on the stream कि हाँ भाई ऐसे ही आंसर आ रहा है. I have to do it. I have to do it. Otherwise it would be injustice to the stream. 4 pi into 8.85 10 raised to the power of minus 12 into 1110 10 raised to the power of minus 12. This comes out to be, yes, 130 volts is your total electric potential at x is equals to 10 picometers. Now you have to calculate the voltage when x is equals to 30 picometer. Again, same thing. Total electric potential is equals to the electric potential due to proton plus the electric potential due to the electron. Apply the same formulas. प्रोटॉन का इलेक्ट्रिक पोटेंशियल किस तरह निकालोगे? चार्ज ऑफ प्रोटॉन 4 पाई ई नॉट एक्स प्लस charge of electron 4 pi E naught. Now, this time you will not have 1110 picometer as the distance from the electron. थोड़ी सी चीज़ें अब change हो गई. Now, if you realize the total distance is still remaining 120 picometer. Total distance अभी भी 120 picometer है. This time the value of x is 30 picometer. What will this remaining value become? बेटा ये remaining value क्या हो जाएगी? 120 minus 30, that is 90 picometer. तो इलेक्ट्रॉन का डिस्टेंस क्या हो गया फ्रॉम पॉइंट पी? 90 picometer. 19 to 10 is the power of minus 12. Simple. Now, can you calculate the total electric potential? Yes. What is the charge on a proton? 1.6. 10 is the power of minus 19. 4 pi. What is the value of E naught? 8.85. 10 is the power of minus 12. What is the value of X? X की value क्या है? 30 picometer. Into 30 into 10 is the power of minus 12. Plus 1.6. 10 is the power of minus 19. Since this is an electron, the charge will be negative. Negative लिख दिया. 4 pi into 8.85. 10 is the power of minus 12 into what is the distance? 90 picometer. What does your answer of voltage comes out to be? बेटा voltage का आंसर क्या आ जाएगा? इलेक्ट्रिक पोटेंशियल का क्या आंसर आ जाएगा? The answer of electric potential after this lengthy calculation comes out to be positive 32. Perfect. On figure 5.1, draw a cross at one position other than infinity where the electric potential is 0. Figure 5.1 का है? Yeah. So the electric potential can be 0 in the middle. बेटा electric potential कहाँ पे 0 हो सकता है? In the middle point. Here. Here at the middle point the electric potential can be 0. Why? Because the electric potential due to the proton will be positive. Electric potential due to electron will be negative. Both of them cancel out each other. Electric potential at the midpoint will be 0. कब होगा electric potential 0? When the distance from the proton is also 60 micrometer or 60 picometer. Distance from the electron is also 60 picometer. So in the middle, the electric potential will become 0. Let's move ahead. Okay. What do we have? So many graphs in this paper. I hope the threshold was low in this paper. On figure 5.2, sketch the variation of V with X between X is equals to 10 picometer and X is equals to 110 picometer. Okay. So at 10 picometer, what was your electric potential? 130. Okay. At 10 picometer, what was your electric potential? 1 second. It was 130, right? तो अब 130 कहाँ पे होगा? If you are going from 80 to 60, you are covering 80 units. If you are going from 80 to 60, you are covering 80 units in 10 boxes. एक बॉक्स किसके इक्वल हो जाएगा? 8 units. Okay. So in the middle, we will have 120, 128. This will somewhere be 130. Perfect. So at a value of 10, you have 130 as your electric potential. Okay. उसके बाद क्या हो रहा है? At a value of 60, your electric potential is 0. At a value of 1110, जब आप 1110 पे चले जाओगे तो आपकी इलेक्ट्रिक पोटेंशियल क्या हो जाएगी? Negative 130, somewhere here. Sir, how do you know that? How do you know that at a distance of 1110 meter, your electric potential will become negative 130? Very, very easy. Just focus on the board. Focus करेंगे at the board. You have realized that at a distance of x is equal to 10 picometer, your electric potential is 130. जब x का distance 1110 हो जाएगा. Okay, let me erase all the other weird stuff here. When x is equals to 1110 picometers, and this distance from the electron is 10 picometers, at this specific point, your electric potential will be equal to what? Electric potential किसके equal हो जाएगा? हाँ जी. जब आपका distance from the proton is 1110 picometer, distance from the electron is 10 picometer, your electric potential will become negative 130 volts. Sir, why? What I am doing is I am taking this exact same equation. बेटा मैं ये exact same equation को ले रहा हूँ. Let me Copy this if I can do it. Copy it. ठीक है. At a distance of 130 micrometer, I will copy this exact same thing. प्रोटॉन की जगह डिस्टेंस क्या आ जाएगा 1110 and the distance from the electron will turn out to be 10. If you just change these values at a distance of x is equals to 130 picometer, you will realize the potential becomes negative 130 volts. That's why here I have marked your electric potential as negative 130 at 1110 picometer. ठीक है. Now you can do one more thing. आप एक और काम कर सकते हो. At a distance of x is equals to 30 picometer, your voltage is 32. So at 30, your voltage is 32. 32 will be somewhere here. Okay. Now do a very simple maths. जब आपका x 30 meters है तो आपका potential difference क्या आ रहा है 32. You can do one more thing. You can do a very simple trick here. क्या कर सकते हो? You can do a very simple trick here. Let's suppose your x key value now becomes 90 picometer. Your distance from the electron becomes 30 picometer. Just flip the calculation थोड़ा सा. प्रोटॉन के डिस्टेंस को आप 90 कर दो. इलेक्ट्रॉन के डिस्टेंस को आप 30 कर दो. Your answer will turn out to be negative 32 volts. So you can also plot another point. At a distance of 90, your electric potential is negative 32. So बेटा आपके पास बहुत ज़्यादा points आ गए. You have 5 points. Draw the graph. Let's choose a different color. Let's choose green. Let's draw a graph that passes through all these points. ऐसे. This is your electric potential का graph. Alhamdulillah, I made a very good drawing. I'm real proud of myself. ठीक है. How did I did this? बेटा ये मैंने कैसे किया? At 10 picometer, electric potential 130. If I flip the distances at 110 picometer, your electric potential is negative 130. Okay. At 30 meters, your electric potential was positive 32. If I flip the distances at 90 picometer, your electric potential is negative 32. In the middle at 60, your electric potential is 0. Simple. आगे बढ़ते हैं बेटा. अच्छा जी. क्या लिखा हुआ है? Two parallel plate capacitors C1 and C2 are connected to a supply that has a potential of Vs. Okay. The capacitors may be connected in series or in parallel. अच्छा जी capacitors को आप series में भी connect कर सकते हो, parallel में भी connect कर सकते हो. The supply provides charge Qs and the plates of the two capacitor acquires charge Q1 and Q2 respectively. Okay. The potential difference across the plates of the capacitor are V1 and V2. Okay. Complete table 6.1 to indicate how Qs, Q1 and Q2 relate to each other and how Vs, V1 and V2 relate to each other for series and parallel combination for the connections of the capacitor. ठीक है बेटा अगर आपके कैपेसिटर सीरीज में लगे हुए हैं व्हाट विल हैपन द टोटल चार्ज Qs is equals to the charge on capacitor 1 is equals to the charge on capacitor 2. However, if your capacitors are connected in parallel, the total charge Qs is equals to Q1 plus Q2. If your capacitors are connected in parallel, the total voltage Vs is equals to V1 is equals to V2. If your capacitors are connected in series, Vs is equals to V1 plus V2. Simple. An isolated capacitor of capacitance this stores energy of this. Calculate the potential difference across the capacitor. आपने potential difference निकालना है across the capacitor. How will you do that? Very, very easy. Energy of a capacitance के 3 formulas होते हैं 1 upon QV. बेटा always remember that the energy stored by a capacitor के 3 formulas होते हैं. Always remember this simple fact. एनर्जी स्टोर्ड बाय कैपेसिटर के तीन फॉर्मूलाज होते हैं, 1/2 QV, 1/2 CV², and the third formula is, that is less known, Q square divided by 2C. This is your third formula of energy of capacitance. ठीक है, ये तीन formulas हैं for energy of capacitance. अच्छा, now here in this equation you are given the capacitance, you are given the energy, and you are asked about the voltage. बेटा आपको energy given है, capacitance given है, आपने voltage निकालना है, तो आप second formula apply कर लो. You will say E is equals to half CV square. What is your energy? 19 millijoules. 19 10 raised to the power of minus 3 is equals to half into capacitance की वैल्यू क्या है? 470 माइक्रोफैराड्स. 470 10 raised to the power of minus 6. वोल्टेज का स्क्वायर. कैन यू कैलकुलेट दिस वैल्यू ऑफ वोल्टेज? वैल्यू ऑफ वोल्टेज निकाल सकते हो. द वैल्यू ऑफ वोल्टेज कम्स आउट टू बी व्हाट बेटा? Value of voltage comes out to be 9 volts. Now you have to calculate the charge on the capacitor. You have the capacitance, you have the energy, you have to calculate charge. कौन सा formula use हो जाएगा? E is equals to Q square over 2C. You can also use this first formula. बेटा first वाला formula भी use कर सकते थे. Energy क्या है? 19 into 10 raised to the power of minus 3. Q square आपने निकालना है. What is the capacitance? 470. 10 raised to the power of minus 6. Can you calculate the charge? Charge निकाल सकते बेटा? Can you calculate the charge? Yes sir, charge निकाला जा सकता है. Charge comes out to be 4.2 10 raised to the power of minus 3. 4.2 10 raised to the power of minus 3 coulombs is your charge. Simple. आगे बढ़ते हैं. The capacitor is now connected in parallel with a capacitor of 180 microfarad. अच्छा जी, अब इस तरह हो गया. Let's suppose you have two capacitors like this. किस तरह से भाई? एक है 470 माइक्रोफैरड्स का कैपेसिटर, एक है 180 माइक्रोफैरड्स का कैपेसिटर. कैलकुलेट द टोटल एनर्जी इन मिली जूल्स नाउ स्टोर्ड इन बोथ द कैपेसिटर्स. बेटा इवन इफ यू कनेक्ट बोथ द कैपेसिटर्स इन पैरेलल, the total charge of the capacitor remains same. That is equal to what? 4.2 10 raised to the power of minus 3. This is your total charge stored on the capacitor. Can we apply this formula to calculate energy? बेटा क्या हम ये formula apply कर सकते हैं to calculate energy? Yes. E is equals to Q square divided by 2C. Q की value तो डाल दी हमने. Can you calculate the total capacitance? Whenever two capacitors are connected in parallel, the total capacitance is 140. Sorry, 240. Whenever two capacitors are connected in parallel, the total capacitance is the sum of the two capacitances. 470 plus 180, 650 माइक्रोफैरड्स. चार्ज क्या है? 4.2 10 raised to the power of minus 3 का स्क्वायर. What is the total capacitance? 650 microfarad. 650 10 raised to the power of minus 6. What does your total energy stored in the capacitor comes out to be? हाँ जी, total energy stored in the capacitor क्या आ गई? 14 into 10 raised to the power of minus 3 joules. 14 millijoules is your answer. Simple as that. Nothing complicated here. आगे बढ़ते हैं बेटा. अच्छा, स्टेट Faraday's law of electromagnetic induction. क्या कहता था Faraday? Let me choose a better color. Green looks really, really ugly. You can say induced EMF is directly proportional to what? Rate of change of magnetic flux linkage is directly proportional to the rate of change of magnetic flux linkage. सिंपल है बेटा. आगे बढ़ते हैं. Let's further move ahead. An aircraft is flying horizontally at constant speed v through Earth's magnetic field as shown in figure 7.1. एक एयरक्राफ्ट है जो कि फ्लाई कर रहा है with a velocity of v through Earth's magnetic field. So here we are given the diagram. The magnetic field of Earth is 38 micro Tesla. Okay. At the location of the aircraft, the vertical component of Earth's magnetic field is 38 microtesla. Here it is written. The distance between wing tips P and Q of the aircraft is 68 meters. अच्छा जी, P और Q के बीच का distance is 68 meters. Okay. As the aircraft moves through the magnetic field, an electromotive force of 0.54 volts is induced between the wing tips P and Q. Calculate the magnetic flux cut by the wings of the aircraft in a time of 15 seconds. आपने मैग्नेटिक फ्लक्स निकालना है. हाउ विल यू डू दैट? वेरी वेरी इजी. डू यू रिमेंबर induced EMF is equals to what? N into change in magnetic flux into change in time. The value of n is equals to 1 because we have a solid object. जब भी आपके पास एक solid object होता है, value of n क्या हो जाती है बेटा? 1 हो जाती है. This aircraft is a solid object. There are no coils on the aircraft. That means n किसके equal हो जाएगा? 1. What is the value of EMF? 0.54. You have to calculate the magnetic flux. What is your time? 15. 0.54 into 15 is equals to your magnetic flux. Let's calculate it. This comes out to be 8.1. What are the units of magnetic flux? Webers. 8.1 is your magnetic flux ka answer. Let's further move ahead. Determine the area of the flux cut by the wings in a time of 15 seconds. Area निकालना है आपने. How will you do that? Magnetic flux is equals to B into A. What is magnetic flux? 8.1. अच्छा जी. What is magnetic flux density? 38 microtesla. 38 10 raised to the power of minus 6. Can you calculate area? 8.1 divided by 38 10 raised to the power of minus 6. What does your area comes out to be? Area किसके equal आ रहा है? This comes out to be 2.1 10 raised to the power of 5 meter square. बेटा ये एरिया किसके इक्वल आ गया? 2.1 10 raised to the power of 5 meter square is your area cut by the plane. ठीक है, एरिया कट बाय द प्लेन भी आपके पास आ गया. ओके, नाउ व्हाट एल्स डू यू वांट? चलो आगे देखते हैं क्या लिखा हुआ है सवाल में. यूज योर आंसर इन बी पार्ट 2 to determine the speed of the aircraft. Okay, so if you humbly realize the area cut by the plane, बेटा प्लेन जो एरिया कट करेगा वो किसके इक्वल होगा? दिस बॉक्स. The area cut by the plane is equals to this lovely little box. अब ये बॉक्स का एरिया कैसे निकालें सर? हाउ डू वी कैलकुलेट द एरिया ऑफ दिस बॉक्स? वेरी वेरी इजी. You have the length that is 68. How will you calculate this breadth? How will you calculate this breadth? Velocity v multiplied by time t. बेटा अगर आपने ये वाली लेंथ निकालनी है, दिस लेंथ, हाउ विल यू कैलकुलेट दिस? वेलोसिटी v इनटू द टाइम दैट द एयरक्राफ्ट ट्रैवल्स. तो आप क्या कहोगे? एरिया a is equals to what? 68 velocity v into the time. Do we have the time? 1 second. 15 second. हाँ, 15 second आपका टाइम है. एरिया क्या है? 2.1 10 is the power of 5. 68 into v into 15. Can you calculate the velocity v? Yes, sir. Just divide the left hand side. Velocity comes out to be 210 meters per second. Easy peasy, lemon squeezy, nothing complicated. Let's see part 4. Use Lenz's law of electromagnetic induction to explain which of the wing tips P and Q is at higher induced potential. The entire game is of induced potential and is of Lenz's law. Let me drink some water, then we continue with this. Okay, so you have to apply Lenz's law to tell which P and Q is at a higher induced potential. Very, very easy. First of all, do you remember what Lenz's ka law state? Lenz's law state that induced EMF or induced current always, always flows in such a direction, induced current EMF always flows in such a direction so as to oppose the change causing it. Oppose the change causing it. Induced करंट या EMF हमेशा उस डायरेक्शन में फ्लो करता है so as to oppose the change causing it. Can you realize what is the force that we are applying? अच्छा, I am removing this. ठीक है. Can you realize we are applying a force towards the right side? क्योंकि एरोप्लेन राइट साइड पे ट्रैवल कर रहे हैं तो we are applying a force towards the right side like this. Induced EMF will flow in such a direction that it creates a force towards the left side. Beta, induced EMF always flows in such a direction so as to oppose the force causing it. We are applying a force towards the right side. Induced EMF will flow such as to produce a force towards the left side. Now I'm opening up the camera. Please don't make fun of how I look. Okay? Now, magnetic field into the page. Where is the force? Towards the left. Where does your finger points? बेटा देखो, थोड़ा सा गौर करो, थोड़ा सा गौर करो. Let me bring this here. Okay. Let me do it at a zoomed out version. देखो, magnetic field into the page. The induced EMF is applying the force towards the left side. Where does your current points? Current points from P to Q. According to Fleming's left hand rule, if the force is towards the left, magnetic field into the page, current flows from Q to P. Let's write this down first of all. पहले इसको लिख लेते हैं. You can say the you can say the applied force, or you can say the induced EMF is produced by applying a force towards right, yeah, in the forward direction. Induced EMF produced हो रहा है by applying a force towards the right or in the forward direction. Hence it produces a force towards the left side or towards the backwards. बेटा देखो, induced EMF produce क्यों हो रहा है? Because you are applying a force towards the right. Hence जब induced EMF produce हो जाएगा, it will cause a force towards the left. Induced EMF produce क्यों हो रहा है? Because you are applying a force towards the right. Hence once the induced EMF is produced, it applies a force towards the left or the back side. If you find all this thing complicated, you can sum this up in a single line. As in the marking scheme, you can say the induced EMF produces an opposing force towards the backside. Towards the backside. बेटा आप जो है फॉरवर्ड डायरेक्शन में फोर्स लगा रहे हो टू मूव द एरोप्लेन. Hence the induced EMF applies the force towards the left side or the back side. Okay. What will further happen? Applying Fleming's left hand rule. Applying Fleming's left hand rule. What will happen? current flows from Q to P. Applying Fleming's left hand rule क्या होगा? Current will flow from Q to P. अब आपने बताना है which one of them is at a higher potential. Which one of them is at a higher potential? Now listen carefully. Okay, so now once this is established that induced current flows from Q to P, the students will make a very evident mistake here. Students कहेंगे कि sir, current flow करता है from positive to negative. This means Q will become positive, higher potential. P will become negative, lower potential. No. Here we are talking about the induced potential. Please focus on the board. अभी important बात शुरू होने वाली है. Beta, let's suppose this is the positive terminal of the battery. This is the negative terminal of the battery. You are correct that circuit के अंदर inside this blue highlighted circuit, you guys are correct that current is flowing from positive to negative. बट बेटा यहाँ पे सर्किट की बात नहीं हो रही. Here we are talking about the EMF source or the battery. Here we are talking about the EMF source or the battery. Always remember, whenever we are talking about the EMF source, induced EMF, or the battery, current flows from negative to positive. This Q will become what? Negative. P will become what? Positive. So you can say, you can write here. यहाँ पे आप लिख सकते हो. You can say, hence Q is negative terminal and P is positive terminal at a higher induced potential. P जो है higher induced potential पे होगा. Always remember that. Simple as that. Nothing complicated. Let's further move ahead. आगे बढ़ते हैं. State what is meant by a photon. Okay, what is meant by a photon? Yes, what do we mean by a photon? Yes, photon का मतलब क्या होता है बेटा? A packet or quantum of energy of electromagnetic radiation. You can say quantum of energy of electromagnetic radiation. Simple as that. Easy peasy. Lemon squeezy. Let's further move ahead. A stationary nucleus of uranium. Stationary nucleus का मतलब क्या है? Initial speed is 0. Undergoes alpha decay to produce a nucleus of thorium. The kinetic energy of the emitted alpha particle is this. Okay. A gamma ray photon is also emitted during the decay. So just for my ease, this is no actual chemical equation. Just for my ease of doing this question, let's do one thing. Uranium 23892 is decaying to form thorium alpha particle and a gamma ray photon. Perfect. This is just for my ease of doing things. Okay. Assume that the rebound kinetic energy of thorium is 0. अच्छा जी इसकी kinetic energy 0 है. Perfect. Table 8.1 shows the masses of the nuclide involved in the decay equation. The mass of uranium 238 is missing. अच्छा जी uranium का mass missing है. Okay. The total energy released in the decay of the nucleus of uranium is this. बेटा ये total energy released है during this decay का process. Okay. Calculate the mass in U for uranium 238 nuclide. Give your answer to 5 decimal places. Wow, crazy. So बेटा ये आपकी energy released है. Do you remember this formula? Energy released in any reaction is equals to the mass defect multiplied by the speed of light का square. व्हाट इज दिस डेल्टा एम और मास डिफेक्ट? बेटा ये डेल्टा एम या मास डिफेक्ट किसके इक्वल होता है? यस, डू यू गाइस रिमेंबर? डेल्टा एम या मास डिफेक्ट किसके इक्वल होता है? द मास ऑफ द रिएक्टेंट्स minus the mass of the products. Okay. Can you calculate the delta M for this reaction? क्या आप इस रिएक्शन के लिए मास डिफेक्ट निकाल सकते हो? जी सर बिल्कुल. What is your energy? 4.274 मेगा इलेक्ट्रॉन वोल्ट्स. मेगा इलेक्ट्रॉन वोल्ट्स का मतलब क्या होगा? 1.6 10 raised to the power of minus 13 mass defect into the speed of light का square 3 into 10 raised to the power of 8 का square. 4.274 1.6 10 raised to the power of minus 13 divided by what? 3 into 10 raised to the power of 8 का whole square. Can you calculate the mass defect? बेटा mass defect निकाल सकते हो? जी सर. 4.274 1.6 10 raised to the power of minus 13 divided by what? 3 into 10 raised to the power of 8 square. Oh, what have I done? Have I done some? Oh, yeah, I got my error. Actually, the calculator is messing around today. Yeah, the answer of mass defect comes out to be what? अब आपने mass defect को भी ना 5 decimal places पे लिखना है. Answer of mass defect comes out to be 7.59822 10 raised to the power of minus 30 kg. Simple. Okay. Now you have to convert it into U as well. आपने इसको U की terms में भी convert करना है. How will you do that? 1U is equals to 1.66 10 raised to the power of minus 27 kg. ये किसके इक्वल हो जाएगा? 7.59822 5 decimal places 10 raised to the power of minus 30 kg is equals to how many U? U की वैल्यू निकाल लोगे कि कितने U के इक्वल हो जाएगा बेटा ये? Let's calculate that. We are short on space. Let's do one thing. इसको हम थोड़ा सा छोटा करके इधर रख देते हैं. ये हमने रख दिया इसको इधर. ठीक हो गया. Now let's do one thing. What will your mass defect come out to be in terms of U? 7.59822 10 raised to the power of minus 30 divided by 1.66 10 raised to the power of minus 27. Oh, 27 भी देखो मैंने किस तरह लिखा. Actually, it's too late here in Karachi, if I tell you guys. That's why the writing is slightly off. 10 raised to the power of minus 30, 1.66, 10 raised to the power of minus 27. The value of mass defect comes out to be what? 4.57, 10 raised to the power of minus. Also, we have to write it till 5 decimal places, na? So let's do it something like this. 4.577 2 and 4 10 raised to the power of minus 3 U. What you can further do is, beta standard form को हटा दो. Take this decimal point 1, 2, 3 यहाँ पे. Mass defect comes out to be what? 0.004 3 decimal places, 4 decimal places. This will become 8U. This is your mass defect. ये आ गया आपका mass defect. ठीक है. अब आपने mass defect नहीं निकालना था. Again, use this journal equation. अब आपने ये journal equation use करनी है. Okay. Mass defect is equals to the mass of reactants minus the mass of products. Mass of products को दूसरी साइड पे ले आओ. Mass defect plus the mass of products is equals to the mass of reactants. Can you realize there is only one reactant? बेटा सिर्फ एक ही reactant है, that is uranium. How will you calculate the mass of uranium? Mass defect, that is 0.00 458U. What are the products? Products क्या हैं? थोरियम है जिसका मास क्या हो जाएगा? 233. ओहो सो मेनी डेसिमल प्लेसेस. 233.915. I in the entire paper I am scared of these decimal places because I am just scared of these decimal places because I can mess these up. 4.000407. 4.000407 U. What does your mass of uranium comes out to be? बेटा uranium का mass क्या आ जाएगा? Put it in the calculator. Mass of uranium comes out to be 273.92016 U. Allahu Akbar. A very big answer. That's why I love significant figures. इस वजह से significant figures are very, very nice. Determine a value for the wavelength of gamma radiation emitted during the decay of uranium 238 nuclei. So now you have to determine a wavelength for the gamma radiation that are emitted during uranium 238 का nucleus. ठीक है. अब बेटा थोड़ा सा focus करो. If you humbly realize you have to calculate the radiation of या wavelength of gamma radiation emitted. The total energy released is this. ये आपकी total energy है ना? This is your total energy. Let's write it down. The total energy released is what? 4.274 mega electron volt. बेटा जो आपकी टोटल एनर्जी रिलीज हो रही है दैट इज 4.274 मेगा इलेक्ट्रॉन वोल्ट. Out of this, the kinetic energy of alpha particle is what? Kinetic energy of alpha particle is 4.2 mega electron volts. What will be the remaining energy for the gamma ray photons? Gamma ray photons के लिए remaining energy क्या हो जाएगी? 4.274. 4.2. I could have done this on the downside as well. 4.274 minus 4.2. The remaining energy for gamma ray photon is 0.074 mega electron volt. बेटा बेसिकली मैंने क्या किया है? बेसिकली मैंने यहाँ पे क्या किया है? द टोटल एनर्जी इज दिस. द एनर्जी ऑफ अल्फा पार्टिकल्स क्या हो जाएगी? हाँ जी, अल्फा पार्टिकल्स की एनर्जी क्या है? 4.0 मेगा इलेक्ट्रॉन वोल्ट्स. द एनर्जी फॉर गामा रे फोटॉन्स की रिमेनिंग एनर्जी क्या हो जाएगी? 4.274 माइनस 4.2 if I am correct. Yeah. अल्फा पार्टिकल्स की एनर्जी क्या थी भाई? 4.2. यस. हाँ जी. Subtract both of them to get the energy of gamma ray photons. That comes out to be 0.074 mega electron volt. Okay. But you don't need the energy, you need the wavelength. What will you do? Energy of any photon is equal to hc over the wavelength. Energy किसके equal है? 0.074. Mega electron volt 1.6 10 is the power of minus 13. What is the value of h? 6.63. 10 is the power of minus 34. What is the value of c? 3 into 10 is the power of 8. Can you calculate the wavelength? Wavelength निकाल सकते हो जी बेटा. 6.63 10 is the power of minus 34 into 3 into 10 is the power of 8 divided by 0.074. 1.6 10 is the power of minus 13. Can you calculate the wavelength? हाँ जी, wavelength आ जाएगी. Wavelength is equal to what? Any geniuses in the chart? 1.7 10 is the power of minus 11 meters. Okay. In practice, the rebound kinetic energy of thorium nucleus is not negligible. अच्छा जी. प्रैक्टिस में आपकी ये जो काइनेटिक एनर्जी है दिस इज नॉट नेग्लिजिबल. दिस हैज सम वैल्यू. लेट्स से 0.2 मेगा इलेक्ट्रॉन वोल्ट्स, या लेट्स से टू make it much more sensible, let's say the kinetic energy of thorium is 0.01 mega electron volts. Okay, just an assumption, just an assumption. Okay, Explain without further calculation how your answer in B part 2 compares with the true wavelength of gamma radiation emitted during the decay of uranium 238 nucleus. Beta देखो, if your thorium nucleus has some amount of kinetic energy, let's say 0.01 mega electrons volt, what will happen? The energy of gamma ray photon or the remaining energy will decrease. बेटा अगर आपके थोरियम आयन के पास या थोरियम न्यूक्लियस के पास सम अमाउंट ऑफ काइनेटिक एनर्जी है, दैट मीन्स द एनर्जी ऑफ व्हाट, energy of gamma ray photon will decrease. If the energy of gamma ray photon will decrease, the wavelength will increase. Why? Energy is inversely proportional to wavelength. तो आप इसको लिख सकते हो यहाँ पे, you can say the energy of gamma ray photons decreases, and this causes the wavelength to increase. Simple. Let's further move ahead. Gamma radiations emitted during the decay of a sample of uranium 238 has a single wavelength. अच्छा जी, gamma radiation की single wavelength होती है क्या? Nuclei of cobalt 6027 decay by beta emission also emit gamma radiation in this process. अच्छा जी, देखो बेटा, अगर आपका कोबाल्ट, अब now this is an AS level question. If your cobalt is emitting by beta emission, what will happen? Mass number remains same. Proton number increases by 1. You will have a beta negative particle. You will have a gamma radiation. Also, you are forgetting one important thing. जब भी बीटा नेगेटिव पार्टिकल इमिट होते हैं या जब भी बीटा इमिशन होती है, यू हैव ए कॉम्प्लीमेंट्री पार्टिकल दैट इज नोन एज एंटी न्यूट्रिनो. हमेशा याद रखो. Suggests why there is not a single wavelength for gamma radiation emitted during the decay of a sample of cobalt 60. बेटा एग्जामिनर कह रहा है कि जब आपका कोबाल्ट गामा रेडिएशन प्रोड्यूस कर रहा है, तो why does this have varying wavelengths? What will you say? You will say the antineutrino produced during the beta negative decay has, बेटा ये एंटी न्यूट्रिनो का क्या होता है? वेरिएबल kinetic energy. Since the antineutrino has variable kinetic energy, the gamma ray photons will have variable energy, hence variable wavelengths. What will you say? You will say the antineutrino emitted during beta, oh, the antineutrino emitted during beta decay has varying kinetic energy, या यू कैन से वेरिंग काइनेटिक एनर्जी कह सकते हो या वेरिएबल काइनेटिक एनर्जी कह सकते हो. ठीक है. द एंटी न्यूट्रिनोज emitted during beta decay have variable kinetic energies. Okay. Hence the energy of gamma ray photons gamma ray photons is also variable, resulting in variable wavelengths being emitted. Simple. आगे बढ़ते हैं. लेट्स मूव अहेड. क्या लिखा हुआ है? स्टेट वेन्स डिस्प्लेसमेंट लॉ. वेरी वेरी इजी. वेन्स डिस्प्लेसमेंट लॉ क्या कहता था? लेट मी चेंज द कलर. आई डोंट लाइक राइटिंग विद ब्लैक. When's displacement law used to state the wavelength at which maximum rate of emission occurs is inversely proportional to the thermodynamic surface temperature. तो यहाँ पे लिख लो. You can say the thermodynamic temperature of the surface of the star is inversely proportional. The thermodynamic temperature of the surface of the star is inversely proportional to what? Inversely proportional to the wavelength at which maximum rate of emission occurs. Simple. Let's further move ahead. Figure 9.1 shows the variation with d minus 2 of the radiant flux intensity observed from star x. ठीक है भाई, f versus d minus 2 का आपको ग्राफ गिवन है. Okay, where d is the distance of the observer from the star. Okay, f versus d minus 2 का आपको ग्राफ गिवन है. Figure 9.2. Okay, let me close the camera. Why is it open up till now? Okay. Figure 9.2 shows the variation with wavelength of the rate of emission of P of radiation by star X and sun. ठीक है. Rate of emission versus wavelength का भी आपको ग्राफ गिवन है. Okay. The surface temperature of sun is this. Okay, we have the surface temperature of the sun as well. State three conclusions about star X that can be drawn from this data. The conclusions may be quantitative or qualitative. अच्छा जी बेटा, हमने स्टार एक्स के बारे में थ्री कंक्लूजन्स देनी है. कंक्लूजन्स कैन बी क्वालिटेटिव और क्वांटिटेटिव. हमेशा याद रखो, क्वालिटेटिव कौन सी कंक्लूजन्स होती हैं? थ्योरी बेस्ड. क्वांटिटेटिव कौन सी कंक्लूजन्स होती हैं? नंबर बेस्ड. ओके. नाउ राइट ऑफ द बैट, कैन यू हम्बली रियलाइज, एक सेकेंड अगर इसको थोड़ा सा फोकस करें, दिस somewhere here is the maximum. No, I don't think this will be 5.1. One second, one second, one second. Let me mark the axes correctly. We are going from 5 to 10. We are covering 5 units. In how many boxes? 5 units cover kar rahe hain. In how many boxes? We are covering 5 units in how many boxes? 10 boxes. एक बॉक्स उसके इक्वल हो जाएगा 0.5 यूनिट्स. Perfect. What is this value? 5.5. So you can say that the maximum wavelength of sun is 5.5, 10 raised to the power of minus 7. Now, can you humbly realize that the maximum wavelength of star X is this? That is 4.9. Oh, not 4.9, 4.5. 1 second. Maximum wavelength of star X क्या हो जाएगी? 4.5. Star X की maximum wavelength is what? 4.5, 10 raised to the power of minus 7 meters. Now let's zoom out a bit. थोड़ा सा zoom out करते हैं. Do you remember, according to Wien's displacement law, the maximum wavelength is inversely proportional to the surface temperature? अब star X की maximum wavelength is less. That means the star X has a surface temperature greater than that of sun. It has a surface temperature greater than 5770 Kelvin. So you can say, यहाँ पे लिख देते हैं, first conclusion तो लिखें so that our work gets less. You can say, since star X has a lower wavelength maximum, it has a greater surface temperature compared to the sun, compared to sun. बेटा सन के कंपैरिजन में स्टार एक्स हैज अ greater surface temperature. What else can you derive here? अगर आप थोड़ा सा फोकस करो, थोड़ा सा फोकस रिक्वायर्ड है आपका, ठीक है. इफ यू थोड़ा सा फोकस ऑन द बोर्ड यू विल रियलाइज वन मोर थिंग. सर क्या चीज रियलाइज करेंगे? What will we further realize if we focus further on the board? Can you look at this graph carefully? We have plotted f on the y-axis and d का square या d minus 2 on the x-axis. Let's take this to the top side. F is equals to L over 4 pi d minus 2. बेटा क्या आपको ये फॉर्मूला याद था? डू यू रिमेंबर दिस फॉर्मूला? द रेडियंट फ्लक्स इंटेंसिटी इज इक्वल्स टू द लुमिनोसिटी डिवाइडेड बाय 4 pi d square. I have taken d square to the top side. This becomes d minus 2. क्या कहोगे आप? What will you say here? You will say, फिर यहाँ पे हम इसको रख दें. You will say that if radiant flux intensity is plotted on the y-axis, d minus 2 is plotted on the x-axis, the gradient of this graph will be equal to what? Gradient of this f versus d minus 2 का ग्राफ will be equal to what? इस ग्राफ का ग्रेडियंट किसके इक्वल होगा? L divided by 4 pi. Can you calculate the gradient of this graph? Yes. This is 0, 0. What is this? 3, what will be this value? Let's see. You are going from 4, you are going from 4 from 8. आप 4 से 8 की तरफ जा रहे हो. You are covering 4 units in how many boxes? 10 boxes. One box is equals to how many units? 0.4 units. ये किसके इक्वल हो जाएगा? 6.4. At a value of x axis का 3, y axis में you have 6.4. Okay, so how about if we calculate the gradient? 0, 0, 3, 6.4. You calculate the gradient y2 minus y1, x2 minus x1. What are the units on the y-axis? 10 raised to the power of 3. 10 raised to the power of 3 are the units on the y-axis. What are the units on the x-axis? 10 raised to the power of minus 23. Can you calculate the gradient? 6.4 into 10 raised to the power of 3 multiplied by 10 raised to the power of minus 23. The gradient comes out to be what? 2.13 10 raised to the power of 26. बेटा ये gradient की value आ गई. Okay. This gradient is equals to what? Luminosity over 4 pi. अच्छा जी. अब now I think I will have to rearrange some stuff ना, क्योंकि we have a space constraint. So let's do one thing. Oh, let's put this here. ठीक है. Now your gradient is equals to what? 2.13 10 raised to the power of 26. What will you say? Gradient, that is L over 4 pi, is equals to what? 2.13 10 raised to the power of 26. Okay. Can you calculate the value of L? Anji, L is equals to 4 pi into 2.13 10 raised to the power of 26. Can you calculate this answer? Yes or no? Can you calculate this answer? This answer comes out to be 2.68 10 raised to the power of 27 is your luminosity. Anyone in the chat who remembers the units of luminosity votes. You can say the luminosity of star X is 2.8 10 raised to the power of 27 volts. Now I think I will have to rearrange everything to create some more space and show you guys the third conclusion. Now, do you guys remember one more formula? This game was exactly about formulas. 1 second. Oh. Also, we have studied one more formula. Luminosity is equals to 4 pi Stephen Boltzmann constant r squared temperature power 4. Can you humbly realize for star x के लिए 4 pi Stephen Boltzmann constant and the value of r all are constant. That means the luminosity directly proportional to temperature power 4. Star X का surface temperature is higher. That means the luminosity of star X will be higher compared to the sun. You can write it here. You can say since the surface temperature of star X is higher, its luminosity. Have I written the spelling of luminosity की spelling सही लिखी है? No, I have made a mistake here. Luminosity. I am feeling sleepy. Its luminosity will be greater as well. Its luminosity will be greater as well. Simple. ठीक है? Let's further move ahead. Star X in a galaxy that is moving away from Earth. अच्छा जी, star X एक galaxy में that is moving away from Earth. Suggest with a reason how the line for a star in X in figure 9.2 would appear differently if it had been obtained from the data measured on Earth. बेटा अगर आप अर्थ पे स्टार एक्स को ऑब्जर्व करोगे व्हाट विल हैपन द लाइट फ्रॉम स्टार एक्स विल अपीयर रेड शिफ्टेड हेंस द वेवलेंथ ऑफ पीक emission rate would be greater. So you will say if observed from Earth, the light from star X will be red shifted. The light from star X will be red shifted. इसके बाद क्या लिखोगे? Hence, the wavelength at which maximum rate of emissions occur will be greater. Beta, the wavelength at which the maximum rate of emission occur will be greater due to the redshift. आगे बढ़ते हैं. Define specific acoustic impedance. We are being asked about the definition of Z. Z की definition क्या होती है? Product of density of the medium multiplied product of density of the medium and the speed of ultrasound in that medium. In that medium. Simple. Okay. Explain how ultrasound waves are detected by a piezoelectric crystal. भाई ultrasound waves piezoelectric crystal से किस तरह detect होती हैं? You will say ultrasound waves hit the crystal, cause it to vibrate. The vibration of crystal produces induced EMF. Ultrasound waves hit, yes, strike the piezoelectric crystal and cause it to vibrate. The vibration of piezoelectric crystal produces EMF या induces EMF, whatever you want to write here. Induces का word ज़्यादा बेहतर रहेगा. I think so. Because in CIs you never ever use produces. Induces ही word use होता है. Induces EMF. ठीक है. Figure 10, table 10.1 shows the specific acoustic impedance for body tissue, water and steel. अच्छा जी, body tissue, water and steel के specific acoustic impedance given है. You have to calculate the intensity reflection coefficient for ultrasound incident on a water steel boundary. Intensity reflection coefficient निकालना है for a water steel boundary. Let's say this is Z2. Let's say this is Z1. What is the formula of intensity reflection coefficient? Z2 minus Z1 का whole square divided by Z2 plus Z1 का whole square. What is Z2 की value? 4.04, 10 raised to the power of 7. What is Z1 की value? 1.48, 10 raised to the power of 6 whole square. What is Z1 की value? 4.04, 10 raised to the power of 7 plus 1.48, 10 raised to the power of 6 whole square. Can you calculate the intensity reflection coefficient? The intensity reflection coefficient comes out to be 0.86. Okay. Explain without calculation what is likely to happen when ultrasound is incident on a body tissue water boundary. बेटा अगर आपका अल्ट्रासाउंड एक बॉडी टिश्यू वाटर बाउंड्री पे इंसिडेंट होगा तो व्हाट विल हैपन? कैन यू सी स्पेसिफिक acoustic impedances are similar? If specific acoustic impedances are similar, the Z key value, oh sorry, if the specific acoustic impedances are similar, the intensity reflection coefficient key value approaches 0. If the intensity reflection coefficient key value approaches 0, all ultrasounds will be transmitted. You can say the specific acoustic impedance, the specific acoustic impedance values, ये देखो ना specific acoustic impedance की values for both of them, the specific acoustic impedance for both body tissue and water are similar. This causes the intensity reflection coefficient to be 0. Hence, all the ultrasounds are transmitted. Hence, सारी की सारी ultrasounds क्या हो जाती हैं? Transmit हो जाती हैं. Simple, that's it for today. If you have any questions, you can ask right away in the chat.